Good morning. This is Ms. Billerbeck, and we're going to talk about 6.3 similarity. So the most important things to think about when we think about similar shapes is that corresponding angles are congruent and corresponding sides are proportional. Okay? Corresponding angles are congruent, corresponding sides are proportional. All right, so if we look at two different triangles here, this is the object and this is the image, and these are similar because we have the corresponding angles are congruent. So this one arc here corresponds to the one arc here. Two arcs here corresponds to a congruent angle right here, and three arcs here correspond to a congruent angle right there. All three of these angles could be the same, or they could be different. So we just want to establish that they don't necessarily have to be the same measure. All right, then we look at these sides. So this side would correspond to that side. So we're going to put the image over the object. So the image is 3 to the 9 and 4 to the 12. So we set up ratios, 5 to the 15. So the image sides are over their corresponding object size. And then when we reduce this, all of these reduce to 1/3. So that's how we know we have a similar shape. So corresponding sides would then be proportional. Now, when we look at, oops, this is example 2, excuse me. When we look at example 1, we have triangle ABC is similar to triangle XYZ. So the order of these triangle, the letters in the triangle are significant. Okay, this means angle A corresponds to angle X, angle B corresponds to angle Y, angle C corresponds to angle Z. So that means that if I look at A should be congruent to angle X, because when it said similar, it told us that. Okay, it told us angle B is congruent to angle Y, and angle C is congruent to angle Z. Now, when we use 3 letters for an angle, angle A, B, C, the middle letter is the vertex right here. So that means angle B. All right, so when we use just the angle denotation with this, that's an object, like a desk. A desk is an object, okay? So as soon as we put that little m in front of the angle, it means the measure of angle ABC, the object. So now when we put an m in there, we're talking about a measure. So we see that because this is congruent to that, and this is angle XYZ, and this is angle ABC, if we want to be very formal, then this is 1/13, so that's 1/13. So we know that already. All right, so when we talk about line segment BC, we put a line over that, and that also is an object like a desk. But as soon as we don't have a line over it, it's a measure of BC. Like my desk is, the desks in my class are 2 feet by 4 feet. That's a measurement. So just like this M is for an angle, which says we're looking for a measurement now, not just an object comparing to another object. Okay, this is saying I want a numerical value, not just we're saying that object looks the same as the other object. We need a numerical value for this now. All right, so let's set up the proportions. We're trying to find BC, so in this case, we probably want BC on top just to make the math easier. So we look at, well, what does BC correspond to? So BC is the last 2 letters here, so it corresponds to YZ. So we can set up our proportion BC over YZ. Okay, so BC and YZ, we have a number right there. That's going to equal, well, now we need to have some sort of scaling. So we need to find two sides that have numbers. So we see AB has a number, and AB corresponds to XY. So XY is right here. So that has a number too. Now BC's on top, so that means we want to keep AB on top as well. So we're going to compare AB over XY. So now what we do is we put in the numbers. So we want to find BC. Well, let's stay with the purple. Okay, we want to find BC. So we have BC, and then YZ is 9 equals AB is 6. So we're just substituting values in here. AB is 6, XY is 10. Now, if I want to get rid of this 9, it's dividing BC. So the opposite operation is multiplying. So we're going to multiply both sides by 9, and that cancels the 9 out. So we have BC equals, and then 6 times 9 is 54 over 10. So that becomes 5.4. So BC then is 5.4. Okay, and we don't know the units, so we can just say units. All right, well, let's go to that example 2 that I almost taught you before example 1. Okay, so example 2, now we're talking about quadrilaterals, ABCD and PQRS. So again, the order of the letters is important. That means angle A and angle P are congruent since they've said that they are similar shapes. Okay, B is congruent to Q, C is congruent to R, D is congruent to S. Those angles are congruent. The sides are proportional. So this is wanting us to find PQR. Now we have to note that Q is the vertex of the angle. So PQR, here's my vertex right here. So this is the vertex of the angle. Okay, we could have gotten away with angle Q because there's no confusion now over what angle Q is. Sometimes there's confusion, so we have to use 3 letters. So in this case, we could have gotten away with just saying find the measure of angle Q. Now we have to find what it relates to. So Q is the second letter here. That's the vertex. So Q goes with B. So we're looking for the angle with B as a vertex. So they give us an angle with A as a vertex and B as a vertex. So we want B. So that means that the measure of angle PQR is 83 degrees because ABC corresponds to PQR. Okay, now they want us to find line segment AB. Okay, so we look at AB is the first 2 letters, so it corresponds to PQ. So AB is here and PQ is here. So let's put AB first since on the top, since that's what we're trying to find, and it just makes the math easier. So that corresponds to PQ. Now we need to find 2 sides that correspond that have numbers. So we see AD has a number, and AD are the first and last letters. So PS are the first and last letters, and PS has a number. So there we have it. So since we have AB on top, we're going to do AD on top and PS below. And now we just substitute. So we don't know what AB is. That's what we're finding. PQ is 25. AD is 16. And PS is 20. Now, 25, AB is being divided by 25, so that means we do the opposite operation and we multiply by 25. And that cancels the 25 out. So we get AB equals, and I do not want to do a ton of multiplication. I do not want to multiply 16 times 25. So I am going to take out the greatest common factor here. So I know that 16 is divisible by 4 and 20 is divisible by 4. So there are 4 4s in 16 and there are 5 4s in 20. Now I also know that there are 5s in 25. So I'm going to take out 1 5 in 20 and 5 and 5 5s in 25. So now I've reduced that whole awful looking thing to 4 times 5, and I can multiply that in my sleep. So AB is 20 units. Okay, so I have 20 units right there. All right, so make it easy on yourself. Take out some greatest common factors before you do the mega multiplication, okay? All right, so I'm going to erase this and we're going to find QR now, the measurement of line segment QR. Isn't that amazing that that one little thing says the measurement of line segment QR? Pretty impressive. We mathematicians do like to save some space and not write a lot of words. Okay, so here's QR, and QR is the 2 middle letters in the name. So that corresponds to BC. Oh, and look, we have a number. So we're going to do QR over BC. And since we know PS and AD are corresponding sides with numbers, we have QR on top, so that means we need to put the PS on top over here, because we need to keep one shape up above and the other shape down below when we're trying to solve for corresponding sides, because they need to be proportional. Okay, that's super important. So you either have one shape up on top, its lengths up on top, you have the other shape's lengths on the bottom. Okay? All right. So now we put in the numbers that we know. We don't know QR. We're trying to find that. BC is 25. PS is 20. And AD is 16. Again, we want to take the greatest common factors out, but first we want to get rid of this 25. So it's dividing QR, so we multiply by 25 to undo that operation, and it's gone. Now we take that greatest common factor out. We take 1 4 out of here and 1 4 out of here, and that's as good as it gets. So now we have to fasten our seatbelts and multiply. So if we think about 5 quarters, 5 quarters is $1.25. So that's going to be 125 when we multiply 5 times 25 over 4. And then if we divide this, there are 3 4s in 12 and 1 4 in 5, leaving 1 left over. So we get 31 and 1/4 units. Okay, so that's how we use the fact that things are similar to find angle measurements and missing sides. Let me show you a quick visual on this as well. So I'm going to share the screen now. And we're going to go to similar shapes. All right, so if I have similar shapes here, this one's obviously, if this is my object and this is my image because it's expanding and contracting here. Now if I bring it over upon the other image and I check the angles, look at that, they're all the same. So the corresponding angles are congruent and the corresponding sides are proportional. Okay, one nests inside the other. Okay, if I make it a smaller triangle, it's the same thing. I move it over, one nests inside the other. And again, if I expand that out, all the angles are congruent, the same measure, and the sides are all proportional. They're proportionally smaller or proportionally larger. Okay, so that's what we're talking about with similar shapes. Okay, so I also want to show you my nesting stars. So these are all similar shapes. Okay, they might be a little beaten up over all the years, but they're similar shapes still. So all these angles are congruent. All these angles are congruent. All these angles, and these, and these. This side is, if I can put this side over that side, and this side over that side, I would have the same proportion. So that's what we're talking about with similar shapes. So you see this a lot in art, similar shapes. In designs for buildings, you'll see similar shapes used. So it's just a very fundamental thing that we like to see similar shapes. It's just a very peaceful thing to see. Okay, so that's now today you have learned the math of similar shapes. Have a wonderful day. Bye-bye.